At the start of my career, I had job titles like junior engineer or software engineer. And at the time, what I was doing didn't really feel much like engineering. Later, I worked in places that didn't really like the term engineering very much, or the baggage that it carried with it. In these organisations, we thought of ourselves as craftspeople, using the skills that we'd honed to create great software. Later still, I worked on a really tough project, doing some difficult, fairly innovative things. And by this time, I was starting to think more about how what worked for us really worked, and that it felt a little bit like we were applying a practical form of scientific rationalism to solving problems in software, which to me is a pretty good description of what engineering is. So I started to wonder if we'd been wrong to reject the idea that what we're doing is engineering. So what do you think? Are you a craftsperson or an engineer? And is craft alone enough to do good work? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. And if you haven't been here before, please do hit subscribe. And if you enjoy the content today, hit like as well. In the early days of computers, software was something of an afterthought. It was seen as easy compared to building the physical machinery. In the 1960s, software started to grow in importance and complexity, and by the late 60s, Margaret Hamilton led a team at MIT tasked with creating the flight control systems for the Apollo missions to the moon. A problem that is as difficult as it sounds, particularly given the constraints of the hardware of the time. NASA were focused on these hardware problems, but the software here was a world-class problem too. To try to get people at NASA to pay attention and take software more seriously, Margaret invented the term software engineering. So she was the first software engineer. Her team were building what they called man-rated systems. The lives of the astronauts depended on their software and it had to work first time. Margaret and her team took a consciously engineering approach to solving these problems. For example, they became obsessed with how things could go wrong. No happy path development for them. By 1968, the idea of software engineering was still very new and not widely used and rather provocative. NATO held the first ever software engineering conference in this year, pulling together experts from the field in an attempt to describe what engineering for software was or should be. Their report was consciously aimed at policymakers and politicians as well as people engaged in building software systems. They saw this as a really big deal and important for the world. Part of the rationale for all of this was to put software engineering onto a firmer footing. They were responding to what they called at the time the software crisis. This was largely the result of computers and their software becoming more capable but also more complex and so more difficult to deal with. Dijkstra said this: "As long as there were no machines, programming was no problem at all. When we had a few weak computers, programming became a mild problem. And now we have gigantic computers, programming has become an equally gigantic problem." I think those computers of the day probably weren't quite as gigantic as he may have thought. But nevertheless, in other disciplines, the move from craft to engineering was a step in effectiveness and capability, allowing for the creation of systems and devices that simply weren't possible through craft alone. So people were looking for a similar step for software. The idea of engineering in software took some pretty big missteps after this. As the explosive growth of the software industry gathered pace and the economic demands for more software grew, the result was engineering became confused with some very bad ideas. But there have always been multiple schools of thought. Remembering the inception of engineering, Margaret Hamilton described her team's approach like this: "We evolved our software engineering rules with each new relevant discovery, while top management rules from NASA went from complete freedom to bureaucratic overkill." As a result, over time, the idea of software engineering became discredited in many circles. Later, in response to the heavyweight bureaucratic approaches of the 1980s and 90s, the agile movement sprang up, followed shortly by the idea of software as a craft. There are still lots of people that call themselves engineers, and there are also lots of people who think that engineering is completely the wrong model. What we do is craft and should be treated as such, they would say. I was one of these people until a few years ago, but I'm not anymore. Now I'm afraid that I think that there is some nonsense that's talked about craft. I read a blog post recently that said software was a craft because we use our hands to type and our eyes to look at screens. What a load of rot. People at SpaceX use their hands and eyes too. Does that mean that they are craft building spaceships? Of course not. So I don't want to try and play a silly straw man game here. I think that there is merit in the idea of craft, but I also think that we can do better than that. The Wikipedia description of software craftsmanship starts with this. While people often misunderstand what skill at coding means, you're never going to get me to argue against the importance of coding skills. My problem with that idea is that I don't think that skill is only related to craft. I can be skilled at sports. I'm not, but I could be. I could be skilled at driving. And of course, I can be skilled at engineering. It's a ridiculous idea to imagine that all engineers produce work of equal quality. Of course they don't. A skilled engineer is better than an unskilled engineer, whatever the nature of the engineering. I agree with the second part of this too. Yes, there was a necessary reaction against misguided commercial pressures and misplaced accountability. But what is this really saying? Craftspeople should be responsible for their work. Well, yeah. But isn't it also true that engineers should be responsible for their work too? Actually, legally, in most parts of the world, in other disciplines, as an engineer, you're more specifically responsible. You have a legal responsibility for a duty of care for your work. If an engineer succumbs to commercial pressure and builds something that hurts people, they're stopped from being an engineer anymore and may go to jail. So if anything, engineering is more likely to solve this second problem rather than less. There is a software craft manifesto. I signed it. I agree with it. But once again, this is not about or limited to only craft. Here are the principles that it outlines. So let's think a little about what these mean. What does well-crafted software mean? I don't think that anyone would say, I prefer poorly crafted software. Whatever measures of quality we choose for a craft-based approach, these will tend to be subjective. A 4-year-old child may like making things, and for their family those things are no doubt wonderful, but they will be judged on different criteria if they were made by someone older with better motor skills. Yet both are the products of craft. How we measure the products of craft is always, by definition really, subjective. Software is notoriously hard to measure, but are we really saying that we shouldn't try? I can tell you the measures that I use to define quality in software. I think that we should adopt these as a basis for defining what quality means and use them to steer our design choices. To some extent, these measures are still subjective, but then so is engineering. It's an illusion to imagine engineering as some cookie-cutter process. It's more like a set of guide rails that provide a sense of direction when we're solving problems. It doesn't prescribe any specific fixed solution, but it does define parameters that will guide us toward good ones and steer us away from bad. Tolerances or stresses and strains in mechanical engineering, temperature, pressure and volume of chemicals in chemical engineering, maybe modularity, coupling and abstraction in software engineering. None of these are mathematically absolute. Engineers don't just crunch numbers and churn out fixed solutions as results. They iterate in design and experiment with ideas and materials to learn and refine their solutions, rather like craftspeople. But their professional guide rails help them to discard ideas that others have found to be bad. As a result, engineers are better able to stand on the shoulders of the people that came before. Engineering disciplines evolve and improve over time. Craft doesn't really have that ability in the same way. The next craft-defining statement in this list is about steadily adding value. This is one of those motherhood and apple pie things. Of course it's true. But once again, can you imagine anyone consciously choosing the opposite? Our goal is to steadily reduce value on the things that we build. Of course not. Value matters, and I very strongly agree with the implicit idea here that we add value incrementally, a kind of process of accretion or evolution, rather than of some genius moment of creation. But this too is a deeply engineering style of thinking. The first aeroplanes were death traps. Many of the pioneers of aviation lost their lives in aeroplane accidents. In 2017, commercial aviation flew the equivalent of 2/3 of the population of the planet, and no one was killed in an aircraft accident. That is the direct result of engineering progress over a period of 100 years in this case. Bit by bit, they try out new ideas. Some of them worked, some of them didn't. Bit by bit, they improved aeroplanes until today you're safer in a plane than you are sat watching this video. Unless, of course, you're watching it in an aeroplane. Engineering is the most effective way that we know of to accrete value in our products. Sorry, but the last two items in the list are just more apple pie and nothing to do with craft. Unless we're saying that engineering disciplines don't have communities of professionals or that they don't have productivity partnerships with customers. My point here is not to disagree with craft. It matters, but it isn't enough on its own. Without some guidance that allows us to differentiate between a well-crafted solution and not, a steer on how to understand when what we do is valuable and when it isn't, approaches that help us to manage our communications and make our partnerships useful and productive, and some agreed structure that we can share that makes us a real community of professionals, then I think the laudable aims of the craft movement are unlikely to be met. In part, in software, we're victims of our history. Software engineering has too often in the past been associated with some fairly terrible approaches that weren't engineering and didn't work to deliver good software. So one of my starting points in trying to define some parameters, some of those guidelines that we can use to help us to find better outcomes, is that however you approach software development, if it doesn't help you to make better software faster, it doesn't count as engineering. In other disciplines, engineering is really just the stuff that works. One of the reasons that I think that we've often made the mistake of confusing engineering with bureaucracy is because we're so used to engineering being associated with physical things. If we are building a chair or an iPhone, the design matters. But the really hard part in making the physical things is to make them repeatedly and at a price. In the physical world, production is the really hard problem. But in software, that's not the case. Software is all about design. Coding is design, architecture is design, figuring out how the UI should look is design. Once we have a design, press a button and bingo, we have a sequence of bytes that represent our system. However big, however complex our system is just a sequence of bytes. Digital assets share a property that is unique to them. However big and complex, we can clone them precisely, usually for essentially zero cost. So in software, our problem is never a production problem. So production line style thinking, which is traditionally what we associate with heavy engineering, is nothing to do with us. We agonize over our designs and then bingo, we can clone as many copies as we like. When we think of real-world engineering, often we think of things like production lines and bridges, but these are the wrong models of engineering for us to look at in software. Ours isn't a problem of production engineering or civil engineering. Our version of engineering is different. because our problem is one of design and our production costs are zero. So a better analogy is to look at something like high-level one-off design engineering. How do design engineers proceed when they don't have the answers yet? They iterate, simulate and experiment and make progress in small steps so that they can control the variables and can better understand their results. So rather than the bridge builder or someone working on a production line, think car designer, iPhone designer, or maybe spaceship designer. The process of designing is all about learning. What do our users want? What kind of software solution could give it to them? How secure does our system need to be? How resilient? How scalable? And so on and so on. This is a mix of sometimes technical things and sometimes more subjective things. Unlike most products of craft, the products of engineering usually have stronger constraints. Imagine for a moment which you'd prefer: a craft-built seatbelt or a craft-built airbag in your car, or an engineered one that's been designed using some maths and some modelling, thoroughly tested and designed to work the same way every time. The constraints, things like the tensile strength of the webbing in the seatbelt and the rate at which airbag needs to expand to save your life, are part of an engineered approach to solving these problems. They rule out many non-viable solutions through those constraints, which is a very, very good thing. This isn't a matter of opinion. Some solutions are just not good enough. We are often not great at this kind of thinking in software. An airbag that depends on the driver blowing it up themselves is really not much use. My point here is that in engineering we need the craft, the skills to manipulate the materials of our discipline, but we also need the constraints to allow us to determine what does good look like. So let's take another look at the craft manifesto for a moment. I'll eliminate the circular reference to craft. So instead of well crafted, let's just say high quality. After all, what does the nature of the craft matter if the output's low quality? If, as I've already mentioned, engineering in general and software engineering specifically is a process of iteratively evolving solutions to problems, then maintaining our ability to change our system is essential to that process. So once our software works, the defining characteristic of quality in software is our ability to easily and safely change it. Sure, performance, security, and lots of other things matter. But if we can change our software easily and safely, we can enhance all of these things as we learn more and more about what's needed. If we can't change our software easily, these things are at risk anyway, unless we're all geniuses who get everything perfectly right the first time. To maintain our ability to change our software then, we need to manage its complexity. So I propose these things as defining the quality of software in general, whatever it is. First, the software works. Then it's modular, cohesive, has a good separation of concerns. It uses abstraction to hide information and is appropriately coupled with a preference towards loose coupling. All of these things enhance our ability to change our software repeatably, safely. These are kind of motherhood and apple pie too. They're not new ideas, but they're a different kind of pie. I can use these ideas to prefer some design choices and discard others. At the extremes, let's just imagine two versions of the system that you're currently working on. One version has all of these things. It's modular, loose coupled, and so on. Now imagine a second version, which has none of these things. There's no modularity. Behavior is spread all over the place, so no cohesion either. Coupling and abstraction are bad and non-existent. So every time you change something, something else breaks in another part of the software. Sound familiar? We'd probably call this a big ball of mud. Now imagine that you need to add a new feature. Which version of the system would you prefer to add it to? I haven't mentioned language or technology here, but still, I'm pretty confident that you'd pick the first one. If, at every level of granularity and design, when faced with a choice, we pick the one that increases these properties and always work to avoid design choices that make them worse, I think that you end up with making better software faster. And that amplifying effect on our skills and talents is the kind of outcome that we'd expect from a genuine engineering discipline. So what do you think? Are you a craftsperson or an engineer? And which one would you like to be? Thank you very much for watching.